In the last few years, language models have seen a huge boom. At the latest with ChatGPT, models for language generation have entered the general audience. However, despite the recent success of generative models, several challenges remain. First, language models are known for making up facts that sound plausible but are factually wrong. This is usually referred to as hallucinating. Also, they are often critiqued for producing biased output. Together with the general lack of explainability of language models, especially in the common chat-based interfaces, this leaves the users at the mercy of the model's output. While chat-based interfaces might be sufficient for a general audience, we identify two user groups demanding explainability of language models. The first group are users with a general interest in exploring and understanding model outputs, which we refer to as language model enthusiasts. The second group are linguistic experts who need explanations to assess a model's learned syntactic and semantic structures, for example, to identify biases in the model output. To address the identified challenges and user groups, we present generAItor, a visual analytics technique for language model explainability and adaptation in generative models. Beam search is the most prominent way to sample the generated text from the probability distribution output by the model. It results in a tree where the most likely nodes are further expanded and less likely branches stall. We argue that the most straightforward way to provide access to a language model's decision process is to visualize this process itself. Therefore, we introduce the tree-in-the-loop paradigm, where an interactive visual representation of the beam search tree builds the central component of our visual analytics technique. By complementing the always visible beam search tree with task-specific widgets, our technique is able to support a variety of tasks. This enables different modes of analysis, such as guided text generation and comparative analysis of model outputs. For example, we support the task of guided text generation by providing widgets to color nodes based on the semantics of keywords, interact with nodes of the beam search tree, for example, to edit the node content or prune the tree, and we include widgets providing an overview on topics touched by the generated text and do guided keyword replacement. In the following demo, I will show how we support the task of comparative analysis. Thereby, we will see how our proposed tree-in-the-loop approach enables new ways to analyze model outputs, generating meaningful linguistic insights. When creating a new tree, the user can enter the comparative analysis mode by putting a placeholder into the starting prompt. This creates multiple instances of the tree based on the replacements configured in the interface. The example shows that the model associates female person names with stereotypical female professions, such as nurse, while male person names are associated with doctor, engineer, and lawyer. In another example, we want to perform a more advanced analysis, showing how our technique allows to easily spot important information in larger trees. For this, we select word lists from different domains that are associated to typical bias in language. This highlights tree nodes containing words from the selected lists, letting us quickly identify nodes of interest. By reducing the tree to the semi-collapsed state, we can preserve structural and keyword information while omitting less important tree nodes. Also, this simplifies the sentiment analysis, which is encoded in the color of the tree edges. To quickly identify common sets in the tree versions, we include an upset plot. It shows in which combinations words from the selected word lists occur in the tree. The example shows how our approach outperforms template-based analysis by allowing the keywords of interest to appear in any position in the beam search tree instead of fixed positions. Also, it inspires hypothesis generation on previously unknown patterns. Besides configuration of models and beam search parameters, exploration and explainability of the beam search tree, and the just shown comparative analysis, our approach also enables guided text generation and adaptation of outputs and models. For this, we provide other, distinct sets of widgets which are tailored to the task they address and work in symbiosis with the beam search tree. Thank you.